want to get right into building phylogenetic trees. But first, we're going to do some more group creation because you can submit groups to these trees. And we're going to go back and do a little bit more with similar genome finder. First, I want us to look for a specific genome. Now, the same Streptococcus genome that we've been building, there's an exact copy of this that's public. So if I write in ANL 2025, and you can do this too, it will search the entire database and it will find that genome, which has been made public for everybody to look at. So let's click on that. And what I want to note, I want us all to do this, copy this number, but also let's look here. Tetracycline, erythromycin, chloramphenicol for susceptibility, beta-lactam, and trimethoprim sulfamethoxazole for resistant. Because one of the things that we're going to be working on, we're going to be doing a number of things, but we're going to be examining if differences in antibiotic susceptibility or resistance, can we see that in a whole genome tree? I don't want to give you any spoiler alerts on this, but you should be thinking about it in your heads and figuring out what that is. Generally, for the beta-lactam antibiotics, a lot of those are single mutations in specific genes. For tetracycline resistance, often that is the presence or absence of a specific gene, TET-M or TET-O. So just hold that in your mind and think about it. So we have our genome ID, and let's go into similar genome finder. So we click here, and then we can paste the genome ID in that spot, and the drop-down box will show us what it is. So I could have written ANL 2025. So we're going to create a few groups here. The first one is using the reference and representative genomes. Let's do 50. We have a low p-value and a low distance, and I'll just click on search here. And we wait a few minutes, and let's pay attention to the Kmer counts. Now, you probably saw these things before, but I'm going to go up to this one that's 57. I mean, it's pretty low, but what the main reason I'm doing this is I want a tree that can have some different species in it because it's a better looking tree, okay? And so I'm going to create a group of those, and I'm going to call it a new group, and I'm going to call it reference strep. And I've created these groups before, so I'm always a little nervous that it'll tell me I've already got this name. And we wait, and it says it's been added. Now we're going to edit and resubmit it. And this time I'm going to want 100 genomes, and I want all the public genomes. Okay, so let's click on this. And we wait, and this will be a little bit slower because if you watch the other videos on similar genome finder, you'll remember that these take a while. And then the next one's going to take even longer because I'm going to repeat it and ask for 500. You may ask, why are you not asking for 500 now? Why do we have to sit through this twice? Well, this will be a nice, neat packet, these 100 genes to submit to the bacterial genome tree. With the other ones, we're going to be doing some filtering on specific phenotypes of these genes. So we'll keep waiting. You remember those old movies where they would hypnotize people with a watch going in front of you? Let's pretend that you've been hypnotized, and we'll come back when the table forms. Oh, before I could even pause it, the table formed. Note here, as has been mentioned before, the Kmer counts are a lot better because the reference genomes are a constrained bunch, but all the public genomes are pretty good. And you know what? I'm going to take like 90 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this guy. And we're going to demonstrate how the tree looks when it's got a good distribution, and how if you have a good outgroup, it really makes the relationships pop within your in-group. That's the sole reason I don't have any particular fondness for these genomes. So I'm going to say group, and it's a new group. And I'm going to say almost 90 strep pneumogenomes, just so I can find that group. Add that. All right. So it's been added. And now one more, edit and resubmit. And this time 500. So we're going to wait. And rather than blather on, I'll just come back when the table is returned. And so once this table is returned, we're collecting all of these for the main purpose of I want to give you some skills on trimming down a group. So I'm going to create a new group, 500 strep genomes, and add that. Okay, it's been added. Now watch closely because I want you to do this yourself. Go up into workspaces, click on genome groups. And then when I get to this group, I want to go to the genome view. So we click on that. Now, the landing pages, you've seen a lot of per genome, and I haven't shown you per taxa, but you can step up and see data per taxa. But this is for a specific group. And right up here, you can see it's showing you resistant and susceptible genomes. And here we have beta-lactam. That was one of the ones we were looking at. Tetracycline, that's one of the ones we were looking at. Chloramphenicol, it looks like most of those are susceptible. Let's here go up into AMR phenotypes and click on that. And now on this filter, and you click on the filter icon and it opens it. And if I clicked on beta-lactam, because that was one of the phenotypes of the genome of interest, if I click on that, we've got 371 resistant, 79 susceptible. And when I see this add a boost, I know that a lot of this is computational. If I clicked on laboratory method, it would be 14 non-susceptible, 6 susceptible. This doesn't really look good. So if I click off on that, the add a boost, I want stuff that has actual data. But moreover, resistance at 371, the tree building pipeline accepts up to 100 genomes. So this is going to be too much. Just for our example, now if this is your data you're playing with, you're going to dig into those genomes. You're going to try to find ones that are good quality. You're going to be hitting it if you want it to do something similar. So I'm going to click that one off. And I already know because I've looked at it, tetracycline. And look, there's a huge number there, 796. And when I look at resistance and susceptible, that's 597. But one of the things that gives me hope is these are laboratory typing methods, not a computational method. So there might be numbers here that we can easily show in the tree without having to do even more pruning. So let's just click first on the resistant. And I could do broth or disc diffusion. So I'm going to click off that and I'm going to look at the susceptible. Oh, and look at that. So for disc diffusion, we have 42. For broth dilution, we have 90. So I'm going to take that because there were 8 in the resistance. So this will be a tree that's right about the max. So I'm going to click on that. So I have 90 genomes here that are all by a laboratory method. And you can even see there's a PubMed identification. So if you wanted to read about this study, you could do it. So click all of those. And I'm going to create a new group called be careful how you name these groups that are going to appear in the tree, because we're going to color the tree. And one of the things we can color it by is the group name. So if you make it really long, it's going to go with the first few words. So with that in mind, sus, petra, rock. Okay, and I could put, like I say, it's always good to have something so that when you come back months later, you know what that was. I mean, you may be working on publishing this and you want to go through your workspace and find it. You want to see by the name something that resonates with you. So I'm going to click add. All right. And now I want to click off susceptible and click on resistant. Click all of those. Then I click the group icon and it's a new group. And I'm going to call it res, pet, broth, strep. Okay. So what we did was we created a group of the reference genes from Similar Genome Finder. We created a group of the closest public Streptococcus pneumoniae genomes from Similar Genome Finder. And then we created a group with 500 of the closest Streptococcus pneumoniae genomes from Similar Genome Finder. Then we took that group and we filtered it based on antimicrobial resistance phenotype. And we captured some genomes that were either susceptible or resistant to tetracycline in a broth dilution method. So we have those groups. And now we're going to build some trees. So buckle up. It's about to take off.